For number 2, look at page 270. It discusses the empirical rule. And then also right on the next page, 271, there's more explanation about it so you can really understand what it's saying. Section 7.6 discusses the normal approximation to the binomial distribution. It starts on page 316. And on the first page, it states at the bottom that under the correct conditions, the conditions stated below, the normal distribution can be used to approximate the binomial distribution. So carry on to the next page, page 317, and the conditions are stated right here that are needed for the normal approximation to the binomial distribution. Are also highlighted in red here. For number 10, you're supposed to describe the distributions of x bar, the sample mean, for various sizes of n. So for 3 different situations here. So discuss what type of distribution it'll be, and then also discuss what the mean will be of those distributions, what the standard deviation will be of those distributions for all 3 scenarios, n equals 4, n equals 16, and n equals 100. You need to find the probabilities for all 3 parts here, A, B, and C. And if you look at page 287, it discusses how to work with normal distributions when you know the mean, the standard deviation, how you can convert to a z-value, and then you can use table 3 in the back of the book to look up the probabilities. Or you can also do them in Excel, and on page 289 it discusses how to use Excel. You're going to use the norm.distribution function. And let me just show an example. I'll work through the same example that's on page 287 of the book, or do some of those. So on page 287 they say that the mean is 10, the standard deviation is 2, and this is the example 5 on page 287. And then so you want to find the probability that x is between 11 and 14. Probability that x is in between 11 and 14. So to figure out for 11, you use normal distribution. 11, type in the number, and then the mean, then the standard deviation, and then true. And so it gives you, true is to give you the probability that x is any value from 11 on down. So cumulative is from 11 on down to 0. And then for 14, you type in 14, 10 for the mean, 2 for standard deviation, and again true. So this is the probability that x is any number from 14 on down to 0. So what's the probability that it's in between 11 and 14? Well, you just need to subtract those 2 numbers, C1 minus A1. You always find the probability in between by looking them both up and then subtracting. And that's the same number they get in the book on page 287. And let me just illustrate that. When you use the probability table or Excel to figure out the probability that x is less than or equal to 11, you get 0.691462. That's what we got when we typed in 11 in Excel, or you can get that from the table in the back of the book. So visually, the chances that x, if the mean is 10 and the standard deviation is 2, which the problem tells us, the chances that x is anything 11 or less is about 69%. And then the chances that x is anything 14 or less comes out to 0.97725%. And again, we got that from Excel, or you can use the back of the book. So if you think about it, 0.97725% would be all this shaded in purple and all this shaded in green, all those numbers. So if you took that value and you just got rid of the green part, watch what happens when you get rid of the green part. You're left with just the purple part, the stuff that's in between 11 and 14, and that's what we were trying to figure out. What's the probability that we get a number in between 11 and 14? So if you take the number, the chances that you're 14 or less, and you subtract the green part, the chances you were 11 or less, you get what's in between. And that's what our final answer was, 0.285787.